My name is Yolanka Wolf, and I'm the Executive Director of CAFE Foundation. Before we get started with our program, I wanted to take a few minutes to tell you about CAFE Foundation. CAFE stands for Comparative Aircraft Flight Efficiency. Founded in 1981 by the Experimental Aircraft Association Chapter 124 members at Sonoma County Airport in California, for 38 years, the nonprofit CAFE Foundation has supported the development and implementation of clean, efficient flight. CAFE's mission is to advance the development of low-emission flight by fostering and promoting early entry, practical market opportunities. CAFE focuses on three areas: technology, business and marketing, and public education and advocacy. During the 1980s, CAFE Foundation, with support from EAA, ran the CAFE 400, a flight efficiency prize competition in which aircraft flew a designated course and were scored based on a formula of velocity times miles per gallon times weight. The CAFE 400 popularized such innovations as high-intensity ignition systems, lean of peak mixture settings, laminar flow surfaces, and many others. In 1992, EAA proposed that CAFE should turn its talents toward performing comprehensive flight tests of the most popular experimental kit aircraft. To enable this, EAA funded the building of the CAFE Foundation Flight Test Center at Sonoma County Airport. CAFE Foundation produced numerous aircraft performance reports for publication in EAA's Sport Aviation magazine. These were the most comprehensive reports available on small aircraft at the time and included measurements of the aircraft's flying qualities as well as a thorough set of performance parameters. For the last 15 years, CAFE Foundation has turned its focus towards electric flight. In 2011, CAFE Foundation hosted the NASA Green Flight Challenge at our Flight Test Center. The purse was $1.65 million US, the largest prize in aviation history. The competition was also sponsored by Google, who installed the electric aircraft charging station at the hangar. This competition marked an historic achievement in aviation, the first demonstration of practical cross-country emission-free flight. Team Pipistrel's winning four-seat electric-powered aircraft, the Taurus G4, flew nearly 200 miles nonstop while achieving just over 400 passenger miles per gallon. Team eGenius from Stuttgart came in a very close second for the Green Flight Challenge and also won the Lindbergh Prize for quietest aircraft, with a peak takeoff noise of just 59.5 dBA at a 250-foot sideline. In 2007, we convened our first electric aircraft symposium in San Francisco with 9 speakers. This annual conference brings together industry leaders to share the latest developments in electric aviation to reduce aviation's environmental footprint. The conference has grown over the years and has moved from its original home in the Bay Area. We now hold the conference in Oshkosh on the weekend before AirVenture begins, except of course for this year. This year is the 14th annual Electric Aircraft Symposium. For the first time, we're holding the conference online. This year's EAS will take an in-depth look at passenger and cargo markets for electric-powered aircraft, as well as a continuum of electric aircraft designs spanning evtol, electric short takeoff and landing, or eSTOL, flight training, general aviation, cargo, commuter regional, and business aircraft configurations. The EAS program will also take an in-depth look at aircraft certification challenges, in addition to battery electric, hybrid electric, and hydrogen fuel cell propulsion systems. This year's format will consist of 3 half days, each made up of 4 panels with a break in the middle. Each panel will include presentations from 3 speakers and a moderated Q&A. Our list of panel topics are shown here, and there's more information on speakers and registration at our website, electricaircraftsymposium.org. The CAFE Foundation Vertical Flight Society have been working to advance electric aviation for many years. For the past 3 years, Vertical Flight Society has joined us in co-hosting this conference, for which we're very grateful. I want to recognize this year's sponsors. Electra.aero is our platinum sponsor. You'll hear John Langford, electra.aero's CEO, during the eSTOL panel tomorrow. We also have 4 gold sponsors. You will hear Trevor Foster from ES Aero on Thursday in the Electric Propulsion Systems panel, Lee Human from Aerotech tomorrow in the Testing and Certification panel, and Ed DeRays from Saberwing on Thursday in the Market Dynamics panel. evtol.com is our media sponsor and has been fantastic in promoting EAS. None of this happens without the hard work of many people. I want to personally thank Jim Sherman, Ken Schwartz, and Mike Hirschberg from Vertical Flight Society. We make quite a team, and I'm really excited about this year's program. I think that you will find that the panels today will provide you with an overview of the industry. And I encourage you, if you haven't already, to register for tomorrow and Thursday when we go into deeper dives on a number of topics, including several topics that we have not had before, such as eSTOL and hydrogen-powered propulsion systems. So electric and hybrid electric-powered aircraft have the potential to significantly reduce air transportation costs, carbon emissions, community noise, and enable new transportation markets. I hope you spend the next few days learning about this cutting-edge industry that is ready to take off. I'm now going to turn it over to Jim Sherman from Vertical Flight Society, who will review with you the workings of the GoToWebinar platform, and then we'll kick it off with our first panel. Jim?
Great. Thank you, Yolanda, and welcome everyone. A very exciting program today. Just want to point out a few things. First off, we will have each presentation go in order, and then we will do questions if there are time at the end of this session. If you have questions for our speakers, there is a box in your GoToWebinar control panel marked as questions. You can expand that box and type in your question, and it will be available for the moderator to review and pass along and ask the panelists. You also have control of the chat box, and you can therefore talk amongst yourselves while the presentations are going on, and we encourage you to have a broad conversation during the presentations. And with that, I will turn it back over to you, Yolanda, and everyone enjoy and have a great symposium. Thank you.
Thanks, Jim. Our first panel is an industry overview, and we have 4 really great speakers to give you a sense of where we are in the electric aviation industry today. This is the only panel that actually has 4 speakers. I will introduce each speaker before they speak. We probably will not have much time for Q&A for this panel, but we will be going into these topics more deeply in the other panels. But I wanted to make sure that you had a broad overview of the industry. So Willi Tacke is going to kick us off, and Willi is the owner and CEO of several publishing companies, including Flying Pages in Germany, Flying Pages Europe in France, and Flying Pages China. He's published the World Directory of Light Aviation since 1995 and has been working for aviation publications since 1983. Willi is also the organizer and founder of the eFlight Expo, an electric aircraft exhibition at Aero Friedrichshafen since 2009. He also there organized the world's first eFlight show in 2017. Since 2004, Willi's been an aviation consultant for government and private aviation companies in Europe, the US, and China. And he is a specialist in electric aviation, ultralight light sport, and general aviation.
Thank you for the nice introduction, Yolanda, and thank you for setting this event up. in the year of Corona, although we can't hear this word already anymore, I think we have to do something to keep connected. And I think this is the way, this is the only way how we can do without traveling. And as you have already introduced me and what I'm doing, I think we can go the next slide very briefly. Which there are some of the publications, and especially one which is on the lower bottom. We started a new electric YouTube channel. Is something which is the latest thing we have been doing, which goes in the same direction of what you're doing here with the online EAS. And next slide, please. So Jolanta mentioned it's the eFlight Expo, which was the first real show for electric aviation. And I have to say, in the first years, we even had aircraft like the fuel cell flying trike, the first electric aircraft of Pipistrel, the very first volocopter. Those who will remember it, it was like a gummy ball with some arms on it. And then since then it was growing. Now we have one full hall of electric aircraft. We had an electric flight show. And next slide, please. Because we had this electric show from 2017 during the opening day and one time also on the weekend to show what electric aircraft are doing. The one which you see there on the right hand side is the electric aircraft of the Siemens. It's a Siemens Electric Extra, which has an extraordinary performance. And actually, if you think how long an aerobatic program is, this is one of the things where you can use electric propulsion systems already right now for flying. Next slide, please. So next year we will have the Aero from 2020 again with the eFlight Expo. It's postponed, and we will have for the first time an electric rally where people from over Europe, we hope, will come in and fly on, while most of and fly on the course. Some people already announced they will fly on from abroad with an electric aircraft, and we are looking forward to this. Next slide, please. So this is something from Europe, which is especially Europe, and those people around the world which are not from Europe perhaps haven't heard so much about it. In electric aviation, especially on the eVTOL sector, there has been one item which was, I suppose, the most discussed last year, which was the eVTOL regulation, which was put out last year in spring, then discussed, and then in its final version released at Cologne from EASA. And next slide, please. There you can see what is covered by eVTOL, because like there are different approaches from the different authorities how to certify an eVTOL, because that's something which is totally new. So how to go put it to an aircraft fixed wing section, put it to the rotorcraft section, or creating something new. FAA in the United States decided to go having part 23 for the fixed wing and part 27 or 29 for the rotorcraft, and then putting the VTOL aircraft in there. Either if they have wings, there will be more part 23. If they don't have wings and are just mainly a multicopter, they could be in one of the rotorcraft categories. EASA has done a different way. They say it is now the slides are jumping a little bit. They say everything which is more than 2 rotors is a VTOL, and as VTOL there is also eVTOL. So if it's 2 rotors, you're still a rotorcraft, you're a kind of helicopter. Otherwise, it will be a VTOL. Next slide, please. One thing is, which is the main problem which was discussed on this SC-VTOL from the manufacturer side, is that EASA said, okay, these are new aircraft which want to be flown inside the inner villages over a lot of people, so into dense populated areas. So having this said, they said we have to have a higher value of safety, and so that's why they created some item which they called no single point of failure, which is something which you do not have in part 23 or 27. And there was a lot of discussion. Next slide, please. In the discussion, it was said, like, if you go to a normal fixed-wing aircraft, to a general aviation aircraft, in part 23, you don't have this rule, no single point of failure. But for the SC VTOL, this no single point of failure was also taken not only for the lift system, but also for the whole aircraft. So also, for example, for the structure and for the wings. And this is something in some cases you cannot do, because if you have two wings, one wing fall off, you would have to have a second or third wing. And so there are some items which are difficult to put under no single point of failure. Next slide, please. And so the conclusions for this discussion is a bit to have the accepted means of compliance process, which is normal in all certification process. And here, EASA described a way how a manufacturer can work around when he can prove that if you would have a single point of failure, but the whole aircraft is very safe, and you would make a workaround to make the single point of failure not anymore single point of failure, then it would get very complicated, and it would get perhaps more dangerous to do so. Next slide, please. So this is the thing which came out in May. It was the first MOC, so means of compliance for this SC VTOL, which is still out there and which is the base on which aircraft will be certified. And the EASA also put out an SC special condition. Sorry, I didn't mention this before. SC stands for special condition for electric propulsion units. And you will hear later in my talk that there has been now already the first electric propulsion unit certified in 2020. Next slide, please. As this means of compliance and the SC VTOL are very highly discussed because they are the core. Without this, nobody can certify an electric aircraft in Europe with EASA. EASA started two things. One is they have their VTOL and rotorcraft Symposium, which was always held in November or December in Cologne, and which had a very growing attention over the world over the last years. Now they converted this to get more support and to get more public attendance to a rotorcraft show. It's called the European Rotors. It's in Cologne from 10th to 12th November. And in announcement of this, we created, together with Aero Friedrichshafen, with a partner of EASA and the European Helicopter Association in this show, we created a session which you can look online at the European Rotors website. And in this session, David Solar, the head of the VTOL department, is explaining how EASA is seeing the SC VTOL. Next slide, please. And how the means of compliance can be used. And they say, okay, if we want to get VTOL flying, then we have to also get it to the public, to get public acceptance. And this is one of the reasons why they created the show, to get out with the aircraft from the specialist to the public. Because if they want to fly in inner cities, if we want to fly in inner cities, we have to get the public acceptance. And EASA also lined out a long time perspective for European safety, where electric is a very core part. And you can download this paper on the EASA website, like the other papers as well. Next slide, please. So there are a lot of challenges for electric flight and eVTOL, as you already heard. And I mentioned certification so much, not because I like certification and paperwork so much, but without the certification getting done in the US, in Europe, and perhaps in a way that they work together, then we will not get any electric flying done in the future. And there are several items which are on the scope which are not aware, where the people are not aware of it. One of it, I have to hurry up a little bit. I see my time is running. So next slide, please. One of it would be the battery and the energy support, because if you don't have an energy grid which is supporting eVTOLs, no eVTOLs will get airborne. And the thing is, right now, the states, these countries in the world, they are setting up the new grid which they need for electric mobility in other sectors. So if we want to be part of this, electric aviation has to get on. Another part would be the air traffic management for urban air mobility. And there are special companies like AirMap or the German startup D3 are working on it. And there will be, I think, special online discussions also on this in the next time, as there are no real conferences, because this, without this as well, no eVTOL will take off. Next slide, please. From the conference I just mentioned before, we for the European Roaches, we had an interesting put out, which is that the German Automobile Club, one of the largest automobile clubs in the world, they started a program, first a feasibility study, but they also want to start flying with eVTOLs as a substitute or as add-on for helicopter flights already next year. They will fly at the beginning with a 2-seat volocopter. Very interesting. You should watch news on this, especially on the feasibility study. They had very interesting point in there. For example, that more than 65% of the helicopter flights, ADAC, which is the largest supplier of emergency flights in Europe, is done without a patient, where they only transport the doctors. And their ADAC thinks this could be done with VTOLs, cheaper and with more aircraft in a more community serving way. Next slide, please. Volocopter wants to do commercial. So now what I will do, only very quick highlights of developments in Europe over the last year or so. So Volocopter, they want to fly in 22, and they also released their version of a cargo flying, because this is something we will hear later on in the EAS, that cargo flying and electric flying, perhaps not VTOL, but with other drones, will be more likely seen more in the future. Next slide, please. Airbus had his first public flight with the Bavarian Prime Minister, with a city Airbus, and they are continuing the flight program with this vehicle. And you will hear more from them in this year, I only can say at the moment. Next slide, please. Rolls-Royce, there was a big question when last year in Paris, Rolls-Royce announced the takeover of Siemens e-aircraft, one of the driving force of electric propulsion system over the last years. And now it figures out that they, although they have some issues in the airline business due to the reduced airline business, but the eVTOL and the electric system of Rolls-Royce, the development is going on, continuing with full force. There are no people released, and we can hope that all the planned program can get online. Next slide, please. There was an interesting thing happening in the winter, where for the first time an electric aircraft in the Nordic countries crossed the border from Sweden to Norway, and they were flying with less than 10 degrees Celsius, minus 10 degrees Celsius, even colder, and everything worked fine. And there is a lot of support in the Scandinavian countries, and we will hear more about this in one of the sessions tomorrow. Next slide, please. One big event for everybody who is in electric aviation, the first certification for a CSLSA was received by Pipistrel earlier this this June, and the same 2 weeks later they also received the certification for the electric propulsion system. Next slide, please. There are other companies and other interesting programs. I just want to mention very quickly, like the Czech company MGM Compro is working on a hybrid propulsion system for an LSA with a rotary engine, which is a government-supported program in Czech Republic, and another government-supported program there is a electrification or semi-electrification of a commuter aircraft EV-55, a very modern plane, which is in certification with the other right now. Next slide, please. Next, okay. You see, I have a lot of things and I could talk all day about electric aviation. And it's not only my work, it's also my hobby and we like it. That's why we put out our eFlight Journal, which is a magazine. The latest one just came out yesterday. Either you scan the QR code or you just type e-flight-journal.com. You can go there. Next slide, please. The next, okay. Yes, no. This one, yeah, because like EAS and a lot of other people, we thought, okay, we cannot come to shows, we cannot meet in person, though the people also cannot meet the core speakers, the manufacturers, the EASA directly, but like they could do on shows or other travels. So what we created a YouTube channel of the eFlight Journal. And there we will have on a regular basis, we started the first 3 ones now, called eFlight Garden Talks, which are online panel discussions, which we will have on a regular basis. The first ones are, for example, with Pipistrel about all this new project they have and about the certification. And if you check it out, there are very interesting things. I haven't heard about this before, although there was a lot of news about this before. We talked with Tina Tomacic, the CTO, and the founder, Ivo Boscarol. Next slide, please. There will be this, I mentioned before, the European Rotors Show with EASA. It will be a show with exhibits of rotors and rotorcraft and evtols. There will be symposiums, and you should definitely reserve the dates. There will be also gamma meetings along on the electric side, so definitely something to mark on the calendar. Next slide, please. We organized over the last years also an electric forum in China, like everywhere around the world. Probably nobody will travel to China for a forum this year. So we decided to hold it as an online or hybrid forum where we'll have some people in, for example, Beijing at a location, and the rest of the people of the world can join online. Next slide, please. No, this was too quick. One more back. Actually, it's just on the Aero Friedrichshafen with the eFlight Expo, where we'll have also the general Gamma Epic meeting again and an electric flight rally. So something also to mark. It's this year in April, 20th of April starting. Okay, next and last slide. Thank you very much for attention. Sorry if I was too long, and if you have questions, you may either join us over eFlight Journal or just ask questions right now, and I give back to Jolanta.
Thank you, Willi, very much. Our next speaker is Xin Go. Xin is the editor-in-chief for Flying China since its foundation in 2013, the only publication in the Chinese language dedicated to private flying as of today. He's also the editor of eFlight Journal since it began in 2018. Since 2013, he's been assisting with the annual eFlight Expo with Willi and spearheading the force of organizing the annual eFlight Forum in China. He is also an advisor to the first private aviation museum in China. Please welcome Xin Go.
Yeah, hi. Thank you, Jolanta, for your nice introduction. So, hi, my name is Xin Go. I'm an editor-in-chief of Flying China, a publication of flying pages. My colleague, Tacke, has really given a very good introduction of our company or what we do, so I just skip here. I'll go straight to our presentation. Next slide, please. So today I'm going to give you a very brief overview of what's going on in electric aviation in East Asia with a focus on China, because that's where I'm from. So I'm going to cover this 4 subtitles. Yeah, next slide, please. Yeah, so I'm just going to go very quickly through some highlights or key points of the basic information of East Asia, which I think would be relevant to electric aviation. I'm not going to go through all these points. You are certainly welcome to take a screenshot and take a look afterwards. I just like to point out some interesting points. For example, there are 130 Chinese cities with over 1 million residents. That's more than North America and Europe combined. And also, there are a very large number of high net worth individuals. East Asia region also has massive high-speed rail system. Totally, it accounts about 80% of world's total high-speed rail. China has 35,000 kilometers high-speed rail, which takes 70% world's total. So which means that for now, practically in China, that's all these regional air routes below 1,000 kilometers are dead. So which definitely worth of noting for electric aviation, especially for regional electric airplane projects. Next slide, please. So what conclusion can we draw from the previous highlights of this region? So East Asia has large markets, has a high economic growth, has large areas of top terrain, which, well, is good for air transportation, right? However, it also has a very good high-speed ground transportation system, the high-speed bullet trains, which is not very good for air transportation. It has high concentration of population in large cities, which is good for urban air mobility and perhaps cargo drone deliveries. And also this region has large wealthy population, which is good for early adapters. Next slide, please. So next I'm going to talk about some momentum for electric aviation in East Asia. First, I'm just going to touch base of regulation. So all these three countries in East Asia, China, Korea, Japan, all have some very strong tradition in government-led policy making, which means that once the government realizes the situation and once the government is determined to do something, they will promote it aggressively and actively, which we have seen in the past 2 or 3 years. Next slide, please. Yeah, here it is. So here, example of the rulemaking of CAC, the Chinese Civil Aviation Regulator. In the past 2 years, CAC has already released these 4 important policies in regard of electric aviation. CAC is quite active and aggressive to promote electric aviation technology in China. Next slide, please. So the next subject is supply chain and ecosystem. We have been seeing relatively quick developments of supply chain and ecosystem for electric aviation in East Asia, especially in China, simply because this region enjoys some first mover advantages in electric mobility at large. So here are some key points I think worth of noting to think about the supply chain in East Asia for electric aviation. So for example, East Asia has 95% of the lithium battery production of the world, and China itself has about 90% of the global production of batteries. And another interesting point is that Japanese companies have 90% of hydrogen fuel cell patents and electro properties. By the way, I just want to make this very quick disclaimer. I gathered all this information and the data from the internet, from the world, from all these resources, as much reliable as I can, which I think all this information I give here are not that off the chart, but it may not be 100% accurate. So I just want to give a quick reference for this presentation for today only. So, all right. So basically, yeah, that's what I said. East Asia, they enjoy some first mover in supply chain build up for electric mobility at large, and as well as in data link technology, such as 5G and space-based navigation and communication and Internet of Things. Next slide, please. So over the years, we've seen a wide diversification of participants and commitments into electric aviation. For example, automakers. China's Geely made investment in Volocopter and Terrafugia. Actually, there are several more, which they don't want to review at this moment. And Japan's Toyota made some large investment in Joby and, of course, Subaru and the TDK. And, of course, Hyundai made their urban air mobility grand plan at CES Expo earlier this year. Next slide, please. So is there a real market demand for electric aviation use case in East Asia? I believe so. Here are the four key points I think are worth of thinking for electric aviation use case in East Asia. For example, there are 5 billion packages delivered per year in China, 5 billion, which is the world's largest, which is good potential for cargo drone deliveries. And here, when I say cargo drone, I mean some very heavy duty cargo drone with a very high payload capability. And also during the COVID-19, this pandemic also raises the awareness and the demand for cargo drone delivery, which I will illustrate later on. And of course, there's even a shortage of pilots and airports and even avgas across the region. And of course, there is a social awareness for air pollution in this region, especially in China, which is the driving force for electric mobility at large, including aviation. Next slide, please. Yep, so here example of the cargo drone delivery involvement in China. Here is the photo, the image of SF Express cargo drone delivery during the COVID-19 in Wuhan. Next slide, please. Yep, here are some highlights of SF Express cargo drone delivery during the COVID-19. By the way, SF Express is the largest delivering company in China. So yeah, I'm just gonna skip to the next slide. You're welcome to take a screenshot, as I say, to study later. Yep. And here is another example of the driving force for market demand for electric aviation in China, because there's a large shortage of pilots, airports, and avgas. So the CAC, the regulators, and the governments are that's why they are aggressively developing and promoting this electric aviation technology and autonomous flight control and the heavy-duty cargo drone technology in an attempt to solve some of the problems caused by this shortage of pilots and airports. Next slide, please. Yeah, another factor is investments. So basically, East Asia has large amounts capital available for investments, and they have good appetite for venture capital and high risk startup, especially in technology-oriented projects. Next slide, please. So here is my favorite topic, social acceptance, because we all know that social acceptance is a very important factor in acceptance of electric aviation. So what's the situation going on in East Asia? Next slide, please. What is social acceptance in East Asia? Because in general, East Asian, I think overall, are really fond of high tech. They are people there in really embracing technologies, all kinds of technologies. People love high tech. So in my view, and according to the people I know, some quick like kind of a poll, I don't think there will be a severe social acceptance situation in Asia. So in this image, that's just some online streaming video. Next slide, please. Yeah, this is my favorite example of how East Asian people embrace high tech. China Mobile set up this 5G station at the foot of Mountain Everest, so that people can literally send Instagram, and even actually technically we could host this online EAS at the foot of Mountain Everest, actually on the top of Mountain Everest, think about that. I don't know why they set up this station, but yeah, it's just example. Next slide, please. Yep, so people in China can use this VR goggle to take a high definition image of what's going on and what's the weather at the Mount Everest. Don't ask me why they do it. Next slide, please. Of course, sometimes the people in East Asia brace for this high tech go a little bit too far. For example, this example of the ride-sharing bicycle. So we just have to keep that in mind and be aware. Next slide, please. So next, I'm gonna go through quickly of some electric airplane projects in China under these three categories: evtol, of course, and eCTOL, mainly led by light sports aviation, light sports airplanes, and eCTOL, mainly due to the reason I mentioned earlier, because the high-speed rail system is fairly well developed in China and in East Asia as a whole. So that's why we won't see many regional electric airplane projects in this area. And of course, large cargo drone for the reason I mentioned earlier. Next slide, please. Yeah, this is the EHang eVTOL, which is quite well known, I think. Next slide, please. So I'm just going to give a very quick through of this project. This is Geely's project. Next slide, please. Jim, you can just go through these slides quickly. I think this AutoFlight X eVTOL. Yeah, this is another helicopter, and the next slide. Next slide. Yeah, I know you're asking, so here I'm giving to you. This is a full electric conventional helicopter. Don't ask me why they do it. Okay, this is the China's first electric light sports airplane certified by CAC back in 2015, and I flew it back then. And this is the four-seater model of the same team. Next slide, please. Yeah, this is one of the very few regional electric hybrid regional e-commuter project going on in China, developed by a Chinese private company. Next slide, please. This is AutoFlight's large cargo drone. Next slide, please. And we can just go through, Jim, very quickly, because these are just, could you pause here? Could you go back? I just want to make a quick comment. So you can see that a Chinese company, they really just adopt all kinds of airplanes to try out this autonomous flight control, including this antique Antonov 2. Next slide, please. Yeah, there's another single turbine, and there's a large cargo drone prototype. Next slide, please. And this is the Siemens, the Diamond Siemens hybrid project, because Diamond company is acquired by a Chinese company. Next slide, please. And the Czech Republic Skyleader electric prototype, which is also acquired by the Chinese company. Next slide, please. So this is a quick wrap up, and you can take a look. So the conclusion is that for anyone who wants to be a global player, East Asia region cannot be ignored. Next slide, please. So if you want to find out more about electric aviation situation in East Asia, in China, please welcome to our eFlight Forum. As Willi Tacke has already mentioned, we organized this eFlight Forum in China since 2017, and you can come to meet all the aircrafts, OEMs, suppliers, especially suppliers, and perhaps investors. Next slide, please. So here are my email address and some useful websites for you for reference. And thank you very much. And Yolenka, I give it back to you. Thank you.
Shin, thank you very much. That was a wonderful presentation. Really happy that you're able to give us the East Asia perspective. Our next speaker is Greg Bowles. Greg is head of government affairs for Joby Aviation. He engages the aviation community and policymakers to advance the introduction of a new generation of local air transportation that is so safe, quiet, and cost-effective that it will become a part of our daily lives. Previously, Greg served as the VP of Global Innovation and Policy for the General Aviation Manufacturers Association, and prior to that, he held positions with leading rotorcraft and airplane manufacturers in advanced design and regulatory roles. Greg's a member of the ASTM Board of Directors and a fellow of the Royal Aeronautical Society. Well, please welcome Greg.
Thanks a lot. Thank you very much, Yolanda, and to all my other friends on the panel, and certainly everybody that we're all watching together. I know we're often together in the sunny fields of Oshkosh, but this will have to do this year. I hope everyone is well. I hope everyone is safe, and I'm going to run quickly so we can get through everything here. If we jump to the next slide, please. So just as a quick reminder, so Joby Aviation, at Joby, we're commercializing piloted all-electric airplanes that can take off and land vertically. And we are also planning to be the commercial operator of those aircraft under essentially FAA Part 135 using commercial pilots. Jump to the next one, please. And at Joby today, we live in essentially 3 places, San Carlos, California, Santa Cruz, California, and Marina, California. We have a pretty good team and lots of hope that many of you will join us. So I know we have a lot of opportunities on the website, so please check us out. Next one, please. So I wanted to quickly walk through why I'm excited about this at a high level, and then I'm going to delve into the technical details about how we're getting through some of the key roadblocks that we've seen. There's something called the Marchetti constant, and essentially that says that dating back to Neolithic times, every day, the average round trip of we humans is around 1 hour. So what that means is we typically migrate away from our homes 30 minutes and back 30 minutes. That's like our natural pattern. That's about how far we like to be away. Over time, when transportation gets faster and more efficient, we still spend 30 minutes, but what that means is we can travel farther and we can do more things with our lives when we're off of feet. So if you jump to the next one, please, thank you. So if you think back to ancient Rome, it was a city defined by foot travel. So in the early days, you'll find many ancient cities about 1.5 miles in diameter. So that's 30 minutes on foot. And if you think back to what happened during Roman times, they started to expand roads to enable carriage and horse travel. In fact, Romans built 50,000 miles of roads. A lot of those still exist in Europe today. Jump to the next one, please. And so with those new cities that were enabled by horse and carriage, you'll find that those cities are typically about 2.5 miles across. So medieval Paris, the inner city of London, walled Beijing, those cities are about 2.5 miles in diameter. Think about what people back then were thinking, right? My day, my forefathers could only go 1.5 miles. They had to go to the baker, and the community was small. Communities nowadays, 1800s are twice that size. So that was like a major technological advance. Can we go to the next one? And then the steam engine allowed us to go 20 miles an hour. So we had a 10-mile circle of influence. Cities like Chicago, New York, those cities were defined by train travel. Next one, please. And of course, the car. So today with car travel, we see that modern car cities in the US like Atlanta are defined by car travel at roughly 15 miles across. And it's defined our current society. If you jump to the next one, please. And thinking back to the 1950s when we built the highway transportation system, that was a major piece of importance for the US. So out of World War II, the US invested in highways that it was called the Defense Highway Act of 1952. I forgot the number, I apologize. But during that time, that investment was really important. It has kind of led into the economy and the life we all live today by enabling us to all use car travel efficiently. Jump to the next one, please. So let's think about what we're about to introduce. By not only creating these green, quiet, safe forms of transportation, but by making them something that can be accessible, that we can do on a daily basis, because cost and the efficiency of use is there, we can enable humans to have up to 80 miles, 90 miles, maybe 50 to 100, we could call it, depending on the exact vehicle. In 30 minutes, you can move those distances. It's like 5 to 10 times the effectiveness of today. And what's amazing about this is it doesn't actually introduce sprawl. This connects us on a point-to-point basis. It connects communities. It connects, you know, where people live, where people play, where people work. And it's a really powerful tool that can. It's a really powerful thing that excites all of us. Let's jump to the next one, please. So I had a chance to see Mike's slides, and I'm not sure if we're going to get to see them or not, but he listed some key challenges. The first among those was technology. So at Joby, one of the things we're working on is technology. And so we've talked about this publicly, and you can see the aircraft on the website. We're relatively quiet about what we're doing, but here's one of our photos of our aircraft. Basically, we've introduced technology that flies 200 miles an hour, over 150 miles with a reserve. It's 100 times quieter than conventional helicopters and conventional aircraft. It can eCTOL and VTOL, so it can do conventional takeoff and landing like an airplane, or it can do VTOL like a rotorcraft. All electric and no single points of failure. Very highly reliable and redundant aircraft. And this is piloted, as we mentioned, so it's not a unmanned aircraft. It's piloted. And so we think that from a technology standpoint, all of the building blocks necessary to field that exist at the levels we're showing you here. This basically holds 4 passengers and a pilot, so it's a 5-seat aircraft total. And this is something that does not require any new science at this point. Every development that happens from now forward makes these numbers and these activities better, but and we anticipate that we'll see that over the decades and half decades. We'll see ranges and capabilities continue to grow, and so that's really exciting. The next one, please. So we talked about the Highway Act, but when we look at infrastructure in the U.S., we have over 5,000 civil use airports here in the U.S. As a result of the Federal Airport Act. And so back then, out of World War II, the government in the U.S. decided it was an important investment to enable aviation and surface transportation, and those infrastructure investments paid off big time. They've kind of created one of the strongest economies in the world. Thinking this way, all around the world, Zin, as you just kind of talked, thinking about this all around the world, if we were to try to come out of Corona, the situation, the economic disaster that's befallen us at this point, if we try to come out of this in the best way possible, these are the kind of investments we should be thinking about. We should be thinking about right now, how do we educate local communities on what's available in the next few years? And how do they avail themselves of that transportation so that people can be enabled to move those 50 to 100 miles on a daily basis? Think about the economic power of that. Countries that take advantage of that will be second to none. And so it's really important thinking. And I think it starts easily. I think it starts with grants to let cities understand and plan for where that infrastructure would go. And then with good planning documents and good education in the cities and communities, there can be grants to build out that infrastructure, which is pennies on the dollar compared to the highways of the traditional airports. Let's jump one more forward. So what is the infrastructure we need? So it doesn't bend the mind. These aircraft can land on runways. These aircraft can land on heliports. These aircraft can land on what we will call vertiports. And so the question is, what exactly is a vertiport? I've heard a lot of discussion. I've kind of thrown my thoughts up here on where we go. So while we can certainly use in the early days airports, runways, heliports, creating vertiport infrastructure, essentially I think that means we're looking for heliport-like objects that are a little more noise sensitive so that they can be brought closer to people, that don't necessarily allow liquid fuels, so you don't have to include the protections against liquid fuels that you would, like the foam suppression systems that can make it hard to put heliports in certain locations. They would need charging infrastructure. Later, over time, I think we envision great success. I think we all see this and we get excited and we envision the end state of like an amazing level of success. And at that point, once we get to those levels of success, we're going to need to have connectivity. We're going to need to have throughput in these resources, because as always, the resources on the ground will define capacity. The airspace goes up cubically as you move away from a point. So there's essentially infinite airspace. We need to set aircraft down on the ground, and a lot of them are going to want to go to the same place. So a lot of the work needs to happen in and around the vertiports, but that's frankly, for later days. I mean, I would anticipate we're probably looking at least the first decade of pretty low density operations in a relative scheme. If you look at how many aircraft arrive at Oshkosh every year, that's a pretty intense situation. And so, that's food for thought. I think if you all know Rex Alexander, Rex, I think I used your symbol there that I had seen on one of the ASTM standards. So I'd ask us all to jump into ASTM, into SAE, into NASA, into the FAA conversations. You're okay, all the key conversations that are happening, so we can shape this stuff together. The next one, please. From an airspace perspective, I won't go through this, but essentially these aircraft will operate in all airspace using traditional equipage in the early days, and then over time we'll probably see additional equipage come online to become more efficient, and that's food for thought that we all need to work together. But there's nothing preventing us right now from operating these aircraft in traditional or even much grander scale than traditional aviation. It's when we get to the several orders of magnitude that we start to have to bring these systems online. Next one, please. So from a pilot qualification standpoint, I just want to discuss where we stand today. So if I become a pilot in a single engine airplane today, like the vast majority of new pilots trained in like a Cessna 172, for example, I'll get a single engine land airplane class rating. And I won't have any endorsements off the bat. Next one, please. And yeah, there you go. From that, there's a whole bunch of endorsements I can get. So if I decide I want to fly an airplane like in a 172 RG, a retractable gear 172 that has adjustable pitch propellers and flaps, that becomes a complex aircraft, and I can get a complex endorsement. If I fly a tail dragger, I can fly that aircraft for a little while and I get a tail dragger endorsement. If I want to fly something higher power, I can go above 200 horsepower and I can get a high power endorsement. In fact, with that, I can fly things as complex as the Pilatus PC-12. So pilots trained on those fixed wing aircraft have a huge purview based on their experience and training, and that's today's system. So let's jump one more forward. So going forward, I think from a perspective of this industry, we've all looked at what's happening in the pilot ranks. Helicopter pilots today, there's around 15,000 helicopter pilots. There are, there are around 300,000, 250,000 commercial and ATP pilots. Private airplane pilots, there's like 170,000, and then those student pilots, like 120,000 student pilots trying to become some of these new kinds of pilots. So it's important to be able to take advantage of all those kind of pilots coming online. Almost everybody I've seen discuss this, whether from an autonomous standpoint or from a heavily automated standpoint, it doesn't seem like a stretch of the imagination that what's important for piloted aircraft of this type is the air-mindedness piece, the understanding of airspace, the understanding of communications, the understanding of how to manage systems. The stick and rudder skills, the traditional stick and rudder skills that one probably perfects with that tail dragger endorsement, those kind of skills aren't necessarily as prevalent in these kind of aircraft. And so what that does is it lets us open up to a broader range of folks. So today in Corona times, it's really unfortunate. A lot of my really good friends are pilots, and a lot of them are looking for things to do. Hopefully we can get things online quickly so that we can find some awesome opportunities for everyone to fly aircraft that are exciting and fun. But the characteristics of traditional pilots fit very well into these categories. The next one, please. So from a broad standpoint, I've heard this from Willi and from Zin and Yolanka. The airworthiness category here in the US under the FAA system, most of the evtol manufacturers are looking at using the flexibility of the new Part 23 plus special conditions. There's interest in putting these aircraft onto Part 135 on-demand operating certificates. And we just discussed the pilot piece, commercial pilots with either 500 or 1,200 hours based on VFR or IFR flying. And that would enable a commercial operation that can do today could do eCTOL and VTOL. So none of that requires anything drastic, but to perfect this and to make it more and more efficient, that's where we have to put our heads together and we have to work to make all the system more efficient and evolve the system. It would be a little bit foolish of us to try to think we could change an existing system that's very mature without even having our foot in the door yet. So this approach to fitting into the system today and iterating to make it better for everybody is the right path forward, we think. And so we're excited to do that with especially this team. Next slide. The last piece I'm going to touch on here in the last 1 or 2 minutes is the community engagement part, and that's really important. We've talked a lot about noise in general. We have talked about safety, and we've talked about accessibility. Those things all go to the success of this industry. If we're not exceedingly safe, this industry can't succeed. And so we have to focus on safety top and foremost. With that said, we have to provide benefit to communities so that they see the need, the benefit to everybody, right? This can't be something for one group or class of the population. It has to be accessible for everybody. It has to provide benefit for everybody. When we have cars driving down our street today, we understand that because we all live in a world of cars. We use cars ourselves. They provide us direct benefit. That has to be the world we're moving into. So that means the noise can't be overt. It has to blend in well. The cost can't be extreme. The cost has to be something we can do on a regular basis. And so with that, and with working with all of our communities to see which ones of them want to stand up these activities first, where does this system enable us to all travel 50 to 100 miles in 30 minutes every single day of our lives? Sounds like an amazing future. What a lucky group of folks we are to be able to live in what's about to happen. So enabling this is extremely exciting, despite the really, really tough year that 2020 is. Out of this is going to be amazing. So that's it. Next slide. Thank you very much, Yolanda.
All right, thank you, Greg. Really appreciate that. Because we did run long, we're going to hold off on Mike Hirschberg's presentation. I think he'll do that tomorrow. And we are going to move right into the next panel. So I want to thank Greg, Willi, and Shin for giving us this great start to the conference, a great overview. I know that there are some questions in the chat. And I apologize that we're not going to get to the questions for this panel. We kind of knew that that was a possibility with 4 speakers. I think that we'll try to answer some of them on the run and in the box, and then get to the others as we go forward.